Welcome to the Deep Dive. Today, we're tackling, well, a really central challenge in AI right now. How do we get all these smart, individual AI agents to actually work together?
Yeah, it's a big one.
It feels like having this amazing team, but they're all stuck in their own little offices not talking. That's the AI agent silos problem, right?
Exactly. We've built these incredibly capable AI agents, sure, but their real potential, their power, really multiplies when they can connect, when they collaborate.
Like different specialists in a hospital.
Precisely. Think about it. Their collective knowledge is so much greater when they can share info, coordinate care easily. That's the kind of interoperability we need for AI agents.
And that brings us straight to Google's Agent2Agent protocol, A2A.
Mm-hmm.
This framework seems designed specifically to be that connective tissue, enabling communication, interoperability between different agents.
That's the goal.
So our mission today is pretty clear. We want to really understand this A2A protocol inside and out, figure out what makes it tick and why it's important for you listening.
And to do that, we've pulled together quite a bit of material. We're looking at case studies, seeing how it's used in the real world.
Okay.
Plus the technical docs, of course, the GitHub repos where the code lives, research papers diving into the theory.
And even news articles, blog posts for broader context.
Yep, the whole picture. We want to give you that 360-degree view.
Because the potential here seems pretty compelling. We're talking about, say, an AI in sales, being able to directly talk to an AI in customer service.
Right. Streamlining things dramatically.
Which could totally change how businesses operate.
Right.
Maybe even foster a more open AI ecosystem overall.
That's definitely the vision, breaking down those silos.
Okay, let's dive in. Let's really get to the heart of Agent2Agent.
Right. So basically, A2A boils down to a few core ideas, a few fundamental concepts you need to grasp.
Lay them out for us.
First up, you've got the A2A client. Simple enough. That's the agent or the application that needs something done. It's initiating the request.
Okay, the requester. Makes sense.
Then, naturally, you have the A2A server. This is often called the remote agent.
And that's the agent doing the work.
That's the one exposing its capabilities. It has a specific web address, an HTTP endpoint, that follows the A2A rules, ready to get requests and process tasks.
And I noticed it's often called a black box agent in the documentation. Why that term?
Yeah, the black box thing. It basically means the client doesn't need to know how the server agent works internally.
Like what specific AI model it's using or its internal logic.
Exactly. All the client needs to care about is what the server can do, its skills, and how to talk to it using the A2A protocol. The internal details are hidden, like a black box.
Okay, so how does the client figure out what the server can do? How does it discover those capabilities?
That's where the agent card becomes absolutely essential.
The agent card. Right. I think of it like an AI's LinkedIn profile or a business card.
That's a great analogy. It really is. It's typically a JSON file found at a standard spot, well-known-agent.json.
And this card holds all the key info.
Absolutely crucial information. It's the agent's resume, like you said. It tells other agents how to understand and interact with it.
So what's on this resume?
Okay, first, the basics. The agent's name and a description. The description explains what it does, and it can even use common mark formatting for, better readability.
Like bold text or lists.
Yeah, exactly. Then, critically, it lists the service endpoint URL. That's the actual web address the client sends requests to.
And that needs to be secure, I imagine.
Definitely. For production, it must be HTTPS. You might see HTTP used just for local development, but never live. Security first.
Got it. HTTPS for production. What else is on the card?
Details about the provider who made the agent, a version string, which is important for compatibility, tracking changes.
Right.
There's usually a documentation URL linking out to more detailed instructions. Very helpful. And then it specifies the supported A2A protocol capabilities. Things like whether it can handle real-time streaming updates or push notifications. We'll get more into those later.
So it's telling you not just what it does, but how it communicates within the A2A framework.
Precisely. And importantly, it addresses trust and security.
How so?
It details the authentication requirements. It tells the client how it needs to prove its identity to the server agent.
And is there a default? Or does it always require something?
The spec strongly recommends against having no authentication in production, so you'll usually see requirements listed. Null or empty is really discouraged for anything live.
Makes sense. Security needs to be built in.
Totally. The card also defines the default data formats the agent expects and sends the default input and output MIM types.
Like text plain or application JSON.
Exactly. Text plain is often the default, but it could be JSON for structured data or image pipping or whatever the agent deals with.
And the most important part, I guess, is the actual list of things it can do.
You got it. The agent card includes an array of specific skills. This is the concrete list of tasks the remote agent offers, so a client knows exactly what it can ask for.
Okay. And one last thing on the agent card. What if the card itself contains sensitive info, like an internal URL?
Good point. If the agent card itself needs protecting, maybe it points to an internal-only agent, then the endpoint serving that .wellknownagent.json file also needs security. Access controls are key.
Right.
And a huge security rule: don't put plain text secrets like API keys directly in the agent card, ever.
So where would related config info go?
There's a specific credentials field within the authentication section, but that's meant for non-secret stuff, like maybe the URL for an Auth server or the name of an API key header, but not the key value itself.
Okay, clear distinction. No secrets in the card. So the agent card is like the initial handshake and info packet. What happens after a client finds an agent it wants to use?
That's when a task gets started. The task is really the fundamental unit of work in A2A.
Like a core job to be done.
Exactly. It's stateful, meaning it keeps track of its progress, it goes through different stages, and crucially, it gets a unique ID from the client right at the start.
What kind of stages or states does a task go through?
The spec defines a few key ones. Submitted, just started. Working, actively processing, input required.
Ah, if the agent needs more info back from the client.
Right. Then completed, success, failed, something went wrong, and canceled, stopped prematurely.
Okay, so the task is the overall goal. How do the agents actually talk back and forth within that task? Exchange the data needed.
That happens through messages. Think of a message as one turn in the conversation for that specific task.
Like one text message in a chat thread.
Pretty much. Each message has a role assigned either user, which is typically the client starting things off or providing input, or agent, which is the server responding or doing the work.
And what's inside a message?
A message is made up of one or more parts.
Parts. Like pieces of content.
Exactly. A part is the smallest bit of content. You find parts inside messages and also inside the final output, which is called an artifact.
Okay, so what kinds of parts are there?
A2A defines a few main types. There's text part, pretty straightforward for plain text. There's file part, which is for sending files. It includes metadata about the file and either the file data itself or maybe just a link to it.
Useful for documents, images.
Right. And then there's data part. This one's really important. It's specifically for structured data in JSON format.
Ah, so for sending parameters or getting back structured results.
Exactly. Super useful for any machine-readable information.
So let me see if I follow. A single task might involve a whole series of messages going back and forth. Each message contains parts, which could be text or files or structured JSON data.
You got it.
And when the task finishes successfully, the result is packaged up as an artifact.
Precisely. The artifact is the final output, the result of the task. And just like a message, it's built from one or more parts.
So the artifact could be a text report, an image file, a JSON object?
Anything, really.
Oh.
The final report from an analysis agent, the picture from an image generator, the structured data confirming a booking, that's the artifact.
Okay, now what about tasks that aren't instant? Things that take time?
Good question. For those, A2A supports streaming. It uses something called server-sent events, or SSE.
SSE, right.
This lets the client get real-time incremental updates as the task is happening, so you get feedback right away instead of just waiting for the final artifact.
That seems really important for user experience, seeing progress.
Definitely. But what if a task takes really long? Like hours? The client might not stay connected.
Yeah, what happens then?
For those really long-running jobs, A2A has push notifications.
How do those work?
Basically, the client gives the server a specific URL, a webhook, when it starts the task. Then, when the server has a major update or when the task finishes, it sends an HTTP POST request to that client's URL.
So the server proactively notifies the client when something important happens.
Exactly. Asynchronous updates.
And there was one more concept you mentioned. Session.
Yes, session. It's optional, but the client can generate an identifier for a session to group related tasks together. Just helps organize things if you have a sequence of interactions.
Okay, wow. Client, server, agent card, task, message, part, artifact streaming, push notifications, session. That's quite a few building blocks.
It is, but they all fit together logically.
So let's walk through how they do fit together. What's the typical flow of communication?
Right. So the underlying communication uses JSON RPC over HTTPS, basically standard web technologies.
Familiar ground then.
Yep. So step one. The client needs to find an agent that can do what it wants. It finds the agent's agent card, usually at that .wellknownagent.json path.
Okay. Discovery via the card.
It reads the card, figures out the capabilities, the endpoint URL, and importantly, the authentication needed.
Right.
Step two, the client initiates a task. It sends a message to the server agent's A2A endpoint.
Using which method?
It uses either the task send method for a sort of standard request response, or it uses task send subscribe if it wants those real-time streaming updates we talked about.
Okay. Send or send subscribe. And what's in that first message?
That first message usually has the user role. It contains the input data for the task, packaged up in one or more. Parts could be text instructions, JSON parameters, maybe an input file.
Got it. Sends the job details. Then the server gets to work.
Exactly. The server agent processes the input based on its skills. Then it sends responses back. These could be intermediate updates, maybe asking for more input if needed, or eventually the final artifact when the task is done.
And you mentioned earlier how important the structured nature of messages and parts is. Why is that standardization so key?
It's fundamental, really, because you have these defined part types, text part, file part, data part. Both sides know exactly what kind of data they're getting and how it's formatted.
Less guesswork.
Way less. Each part also specifies its content type, like application JSON or image dating, so there's no ambiguity. Agents can reliably understand and process the information they exchange. It makes the whole system predictable and robust.
Can you give us a couple of concrete examples? What might a successful task completion look like?
Sure. Let's say you ask an agent, what's the capital of France? The server might respond saying the task is completed. And the artifact would contain maybe just one text part with the string Paris. Simple.
Okay, straightforward. What about something more complex?
Right. Maybe booking a flight?
Yeah.
The travel agent AI completes the task. The response might include a text part confirming the booking in plain English and a data part containing a JSON object with all the flight details, confirmation number, times, seats, everything structured.
Ah, so you can get both human-readable and machine-readable output.
Exactly. Or maybe you ask a support agent AI for open tickets.
Well,
The response could be a data part containing a JSON array, where each object in the array is a ticket with its ID, status, summary, date, etc.
very useful for integration.
Hmm.
Okay, and how does that streaming look in practice if I use task send subscribe?
So the server keeps that connection open and sends back a stream of server-sent events. Each event basically contains a send task streaming response.
And inside that?
Inside that, you'll find either a task status update event showing the task changed state, maybe from submitted to working, or a task artifact update event.
And that's like a piece of the final answer.
Exactly. It could be part of the final text report or a chunk of data being generated. You get the artifact incrementally.
Got it. And the push notifications for the long-running stuff, how does the server send that update?
When the server has something to report for a push-enabled task, like that complex report is finally done, it makes an HTTP POST request to the webhook URL the client provided way back at the start.
And what's in that POST request?
It might have an authorization header if the server needs to authenticate to the client's webhook. The body will contain info about the event, definitely the task and the new status, like completed or failed. The exact payload format can vary a bit depending on the server.
Okay, that covers the mechanics of communication pretty well. Discovery, task initiation, data exchange, real-time updates, async notifications. Now let's circle back hard on security. It sounds crucial.
It absolutely is. A2A relies heavily on standard web security practices. HTTPS for encrypting everything in transit is a baseline.
Right.
And then there's authentication. The agent card, as we said, is key here. It tells the client exactly what authentication method the server expects.
So if the card says, I don't know, bearer authentication, what does the client do?
Good question. The A2A protocol itself doesn't specify how the client gets the credentials. That's called an out-of-band process.
Meaning handled separately.
Exactly. So if it needs a bearer token, maybe the client has to go through an Auth 2.0 flow with some identity provider first to get that token. If it needs an API key, the client has to have obtained that key securely beforehand through some other channel.
So A2A says what's needed, but not how to get it. That allows for flexibility, I suppose.
It does. Once the client has the credential, the token, the API key, whatever, it includes it in the right HTTP header on every A2A request it sends. Usually the authorization header for bearer tokens, or maybe a custom header if it's an API key.
And you stressed earlier, no plaintext secrets in the agent card. Why is that so critical?
Because if that agent card gets exposed somehow, and the actual secret API key or password is just sitting there in plain text, well, game over for that agent's security.
Right, immediate compromise.
Exactly. That credentials field in the agent card is only for non-secret configuration details, like maybe the URL for the token endpoint in Auth, or the name of the header where the API key should go, but never the secret value itself.
Okay, crystal clear on that. The secret stays secret, managed outside the card.
And if even those non-secret configuration details in the credentials field are sensitive, then the agent card endpoint itself needs protection.
Right, access control on the card itself.
Yeah.
Okay, we've got a solid handle on the technical side now. Let's talk applications and benefits. You mentioned cross-departmental collaboration. Can you give a concrete example there?
Sure. Think about a big online store. You've got a sales assistant AI chatting with a customer. The customer mentions a technical problem with something they just bought. Instead of the sales AI being stuck, it could use A2A to securely talk directly to the customer service AI.
Passing along the details.
Yeah, all the context, who the customer is, the product, the issue description. The service AI could then maybe trigger troubleshooting steps or even start a return, maybe even contact the customer proactively, all seamless.
Wow, okay. That avoids the customer having to repeat everything to a different department.
Exactly. Much smoother process, better customer experience, more efficient operations overall.
That's a great example. What are some other areas where A2A can make a difference?
Oh, loads of possibilities. Customer service, definitely escalating from a simple chatbot to a specialized agent. E-commerce logistics, an inventory agent telling a shipping agent to restock or schedule deliveries automatically.
Proactive supply chain.
Right. Finance, different agents, analyzing transaction data, spotting fraud patterns together, flagging things for humans. Basically anywhere you have multiple smart systems that could benefit from coordinating and sharing information.
So it really shines when you have these opaque agents where you don't need to know their internals, just what they can do and how to talk A2A.
That's the core idea. Standardized, secure collaboration.
So what are the big picture benefits for an organization adopting A2A? Let's list them out.
Okay, well, number one is enabling that seamless, standardized collaboration between different agents, even from different vendors.
Which simplifies integration into existing systems, right?
Massively. You get built-in agent capability discovery via the agent cards. You get secure collaboration using standard auth methods. You get proper task management with life cycles.
And that leads to
Increased agent autonomy and productivity. They can delegate, request info, coordinate better. Long-term, it should reduce the cost of building custom one-off integrations.
plus the flexibility to mix and match agents from different providers.
Huge benefit. Avoids vendor lock-in. It helps break down data silos by letting agents share info securely. And the support for long-running tasks with real-time feedback is crucial for complex business processes.
And it handles different data types.
Yep. Its modality agnosticism, text, files, structured data makes it really versatile.
It sounds like a pretty comprehensive solution.
Yeah.
But A2A isn't the only game in town for agent communication, is it? We hear about MCP, for example.
That's right. A2A is part of a larger trend. You mentioned the multi-component protocol, MCP. They both tackle agent interaction, but they have different philosophies, different primary goals.
How do they differ?
MCP often leans towards a more centralized or hierarchical model. Its main focus is often connecting a central agent, like a large language model, to various specific tools or data sources via an MCP server.
Okay, agent to tool.
Kind of.
Yeah.
Whereas A2A is geared more towards decentralized peer-to-peer interaction between agents. The emphasis is on agents collaborating directly to get things done.
Can you give us an analogy, maybe the kitchen one again?
Yeah, the kitchen analogy works well. Think of MCP as the standard way a chef, the agent, uses specific appliances, the tools, the oven, the mixer. There's a protocol for using each tool, maybe overseen by a head chef, the MCP server.
Okay.
A2A is more like how the different staff members, the sous chef, pastry chef, line cooks, all agents talk to each other. Is table 5's appetizer ready? I need 2 more minutes on the sauce. Watch out, allergy on table 7. It's that direct coordination between the specialists.
That makes it much clearer. MCP often agent to tool, A2A more agent to agent collaboration.
Generally speaking, yes.
And what about those other acronyms floating around? ANP, ACP, AITP, Agora, LMOS. Briefly, what are they about?
It's a busy space. ANP, Agent Network Protocol, is about open decentralized networks using things like decentralized IDs for security. ACP Agent Connect Protocol focuses on server-hosted interactions, managing conversation threads. AITP is specifically for secure economic transactions between agents. Agora is cool. It's about LLMs negotiating how they'll communicate with each other. And LMOS, Language Model OS, aims to be a platform for interoperability across different enterprise agent frameworks. So lots of different angles being explored.
Very dynamic field indeed. Okay, back to A2A. Let's really get into the weeds on security. Beyond the basics of HTTPS and Auth, what specific threats and best practices should people implementing A2A be thinking about?
Security is absolutely foundational. While A2A leverages authentication, authorization, who can do what, and encrypted transport, the whole multi-agent setup introduces unique challenges.
What? What are the big security worries?
Well, the agent card itself is a target. We talked about protecting it, HTTPS, access controls, no secrets inside. That's number one.
Protect the front door. Makes sense.
Then you worry about unauthorized agent impersonation, someone faking an agent card or stealing credentials to pretend to be a legit agent.
Ooh, nasty. How do you fight that?
Stronger identity methods like DADs, maybe mutual TLS, where client and server both authenticate using a trusted agent registry. Plus, regular credential rotation.
What else?
Task replay attacks. An attacker captures a valid request and sends it again later to cause trouble.
How do you stop that?
Using those unique task IDs we mentioned is key. Also, adding timestamps and nonces, random one-time values, to requests helps ensure they're processed only once.
Okay, prevents duplicates. What about the data itself?
Crucial to do input sanitization on everything, including agent card content to block injection attacks. Need secure agent card resolution, always use HTTPS, validate certificates properly, maybe even a reputation system for agents.
Reputation, interesting. What about agents giving tasks to other agents? Delegation.
Yeah, abuse of delegated authority is a risk. You need explicit user consent for delegation, really detailed audit logs, and very strict validation of any passed-on credentials or tokens limit their scope and lifetime.
So lots of checks and balances.
Absolutely. And you have to consider malicious agent interaction. What if one agent is compromised and tries to attack others? And even cross-layer vulnerabilities, like a poison artifact messing up a downstream agent. Defense in depth is essential.
Okay, so summarizing the core security controls for any A2A setup.
You need endpoint security, TLS, firewalls, strong authentication and authorization, thorough input validation sanitization, the principle of least privilege, only needed permissions, comprehensive monitoring and logging, following secure development, SSDLC practices, and a solid incident response plan.
And specifically for the A2A server itself, any extra precautions?
Definitely. We hit agent card security hard already. Authenticate every single incoming request. Rigorously protect sensitive actions data tied to the agent's skills, strong authorization checks. Detailed logging and monitoring of server activity. Use rate limiting to prevent DOS attacks or abuse. Stick to secure development practices for the server code itself.
What about for streaming, SSC?
Yeah, protocol-specific security for streaming is needed too. Authenticate the stream connection, manage its state securely, protect against resource exhaustion. And if you're mixing A2A with other protocols like MCP, be extra careful at those integration boundaries.
It's a lot to consider, but sounds necessary for enterprise use. Shifting gears slightly, implementation practicalities. What kind of costs are involved in getting A2A up and running?
Costs can really vary, depends on the scale, complexity, your existing tech stack. The process usually goes planning design, then setup config, maybe a pilot test, then the full rollout.
Are there specific cost drivers? SDKs?
Yeah.
Infrastructure?
There are SDKs available, Python, JavaScript, Java, which help development, but the main costs are usually infrastructure, cloud, servers, network, development, building or adapting agents, and ongoing operational maintenance, monitoring, updates, support.
You mentioned dynamic resource allocation as a potential benefit. Does that actually save money?
It can, yeah. Because agents can delegate and coordinate more dynamically, you might use your computing resources more efficiently. Less idle time, better scaling. So potential cost savings there through better resource utilization.
And for organizations that are maybe a bit cautious, how can they dip their toes in?
A phased implementation is usually the way to go. Start small, pick a specific use case, run a pilot project, learn from that, see the benefits, then scale up. Reduces risk, manages the initial investment.
Okay, makes sense. So looking ahead now, what's next for A2A? What's on the roadmap?
It's definitely evolving. We expect to see more formalized authorization frameworks for finer control, maybe ways to securely embed optional credentials and agent cards to simplify things, improvements in dynamic UX negotiation, making interactions more adaptive, maybe even multimodal, and ongoing tweaks to streaming and push notifications for better performance and reliability.
So continuous improvement. What does this kind of standardization mean for the bigger picture of AI?
I think it's potentially huge. A2A could become a kind of foundational layer, like HTTP for the web, but for agent collaboration. That could really fuel innovation, specialized agent teams, agent networks tackling complex problems. It's a move towards more mature, enterprise-ready AI, getting beyond those isolated
This
systems.
has been incredibly thorough. Let's quickly recap the key takeaways. Google's Agent2Agent, A2A, is all about letting AI agents talk and work together, breaking down those silos.
Right, using core parts like agent cards for discovery and specs, tasks for units of work, messages and parts for structured communication.
It enables collaboration, simplifies integration, boosts automation across different areas, but security is absolutely critical throughout.
And by giving agents this common language, it really does open the door for more sophisticated, collaborative AI systems in the future.
Absolutely. Which brings us to our final thought for you, our listener. As these AI agents get more interconnected using protocols like A2A, what new possibilities and maybe new challenges emerge? How do we manage these complex workflows? How do we ensure trust when agents from different places are interacting? Something to definitely think about for the future of AI collaboration. Thanks for joining us on this deep dive.